All right, hello chemists, and welcome to our Wednesday recap. Today's just a day to review what we have looked at on Monday and Tuesday. So I'd like you to go back and read back through the lessons just to make sure it's all solid. You can flip through the YouTube videos again, and you can make sure your practice is all good. So the last 2 days you got practice sheets, and today I'm going to post the keys, but I also thought I'd just briefly talk through them because that can help getting it in more ways than one. And if you have any questions again, please feel free to email me, Mr. B Science MB, Mr. B Science MB at gmail.com. But yeah, without further ado, and because I learned that my YouTube channel has a time limit, I'm gonna get started. So lesson one, Introduction to Matter and States. Here's are the questions. What are two physical properties that characterize matter? So I'm gonna reveal these answers as we go down here. But yeah, so the two physical properties that characterize matter are mass and volume. Matter has a mass and it takes up space. So it has mass and it takes up space. That's what we mean by properties of matter. It's always going to have a mass and a volume. No matter if it's gas, liquid, solid, whatever, mass and volume, that's for matter. That's what matters here. There's so many matter jokes, I'll try not to make too many. Okay, great. Second, explain and give an example of both an extensive and an intensive physical property. So the difference here is extensive and intensive properties. One is based on the amount of something you have, and one is just based on the characteristics of what you have. So here, if we peek down, we have intensive is something that do not depend on the amount present. So something intensive would be like malleability or conductivity. There's a whole chart in the lesson, but it's things that don't change if you have a small or large sample. They're always just characteristics of whatever compound you're talking about. What I would expect you to know here is you would have to know the difference between intensive and extensive and be able to provide an example of each of them. So on the other side, we have extensive. That would be like mass. Obviously, if you have 3 bricks of gold, it's going to weigh more than if you have 1 brick of gold. So the more you have of a sample, the higher its mass will be. That means it's extensive. Intensive, think looking inward. It doesn't matter about how much you have. Extensive, think like looking outward, how much you have. Cool. 3. What is the difference between a qualitative and a quantitative property? So I do invite you, if you want to just quiz yourself in your head, pause these videos after I prompt you and it's going to answer in your head, or make sure you got it rock solid from your assignment sheet, and then just use this as a like little pop quiz. But what is the difference between a qualitative and quantitative? So qualitative, think quality. It's a property that can be described but cannot be measured with numbers. So color, shape, texture, you wouldn't say, oh, it's 47, you'd say it's red. You wouldn't say, oh, it looks like a 324, you'd say it looks like a circle. Things like that that don't involve numbers and measurements, they're just based on your observation. Conversely, quantitative are a property that is measured when analyzed using a numeric value. So if you weigh something, you're getting its density, you're getting its length, you're getting its height, something that you'd expect a number for. So like volume, mass, length, anything that you'd be measuring and getting a number for. Think quantitative, quantity. So what is considered a physical change? In chemistry, this is an important idea, the difference between a physical change and a chemical change. I'll give you a hint. A chemical change happens in a chemical reaction, whereas a physical change does not happen in a chemical reaction. It's just a change in state or shape. So a physical change would be like if ice melts, or if we bend a metal into like a loop or something, bend a wire. So we're not actually changing what it's made out of or the chemical identity. Like we're not changing it from H2O to OH. It's still going to be the same compound. We're just changing its state or shape. So yeah, here a chemical change would actually change the elements in a compound to something else, like in a chemical reaction, whereas a physical change does not do that. Okay, so an everyday example of diffusion, lots of fun examples here. Two I just thought of are spraying Axe in the bathroom or putting food coloring in water, but you can be creative there. Just anytime you think of something spreading out from areas of high concentration to areas of low concentration. Okay, great. Then how would you explain the state of plasma? This is kind of a tricky one, But for all intents and purposes, we are just going to think of plasma as superheated, superionized gas. So here, we say it is a superheated gas that gets so hot the electrons separate from the atoms, forming positive ions and electron soup. Basically just a very energized form of gas. So plasma, just think super energetic, super ionized gas. Great. Just going to try to block off on the next page too. There we go.